Hey everyone, and welcome. Today we're going to talk about something we literally feel every single day: heat. From the sizzle of a pan when you're cooking to the warmth of the sun on your face, heat is always on the move. So today we're going to break down the three fundamental ways it actually travels.
It's a great question, right? Think about it. You could be sitting a good few feet away from the flames, but you still feel that amazing cozy warmth on your skin. You're not touching it, the wind isn't blowing the hot air at you, so how does that work? It's one of those little everyday mysteries we're going to solve right now.
Okay, so it all comes down to these three main ways: conduction, convection, and radiation. These are our three pillars. You can think of them as the basic rules of the road for how heat gets around. And trust me, once you get these, you are going to start seeing them happen everywhere.
All right, let's kick things off with pillar number 1, conduction. This is probably the one you're most familiar with. It's all about transfer by touch.
The best way to think about this is like a line of dominoes. You knock over the first one, and boom, it passes its energy to the next, and so on down the line. That's exactly what's happening with conduction. You have these hot, super energetic molecules vibrating like crazy, and they literally bump into their neighbors, passing that energy along. It works best in really dense, solid stuff where all those molecules are packed in tight.
Oh yeah, we have all felt this one. You leave a metal spoon in a hot bowl of soup, right? You come back a minute later, and ouch, the handle is way too hot to touch. That is pure conduction. The heat has literally traveled molecule by molecule right up the spoon. Or, walking barefoot on hot sand at the beach. Same exact thing. The heat transfers directly from the sand right into your feet.
But here's the thing, not everything conducts heat the same way. Some materials are amazing at it. We call those conductors. Think of metals like copper or aluminum. They're fantastic because their little electrons can just zip around freely, spreading that heat energy super fast. Then you have the opposite, insulators. Things like wood or plastic. They're terrible at conducting heat. They'd rather just trap it.
All right, pop quiz. Imagine you've got a hot pan. One handle is metal, the other is wood. Which one is going to feel hot almost instantly? Yeah, you got it, the metal one for sure. Why? Because it's a way better conductor.
Okay, let's move on to our second pillar, convection. Now this one's different. It's not about molecules just bumping into each other while staying in one place. With convection, the heat actually hitches a ride and goes somewhere.
The key word here is fluids. And in science, that doesn't just mean liquids like water, it also means gases like the air all around us. So with convection, the fluid itself actually moves, and it carries the heat energy along with it.
The classic example? A boiling pot of water. You heat the bottom, right? That water gets hot, it gets less dense, and it starts to rise. Meanwhile, the cooler, heavier water at the top sinks down to take its place, gets heated, and then it rises too. You get this awesome circular flow, called the convection current, that spreads the heat through the whole pot. Your room heater works the exact same way with air.
And get this, convection isn't just for your kitchen. This is a huge deal on a massive planetary scale. I'm talking about what drives our weather patterns. The movement of warm and cold air creates wind. The movement of warm and cold ocean water creates these gigantic currents that literally shape climates all over the globe. It's pretty amazing.
Okay, time for another quick check. Which one of these is a perfect example of convection? It's the hot air balloon. You heat the air inside, it gets less dense than the air outside, and up it goes, taking the whole balloon with it. That is convection, pure and simple.
And that brings us to our third and final pillar, radiation. Now this is the one that solves our campfire mystery from the beginning. And it's probably the most unique of the three because it doesn't need any stuff to travel through.
So think about it. Conduction and convection both need matter, molecules bumping or fluids flowing. But radiation? Nope. It travels as pure energy in the form of invisible electromagnetic waves. We're mainly talking about infrared radiation here, and it can just zoom right through the total emptiness of space.
The biggest, most powerful example? The sun. Its heat travels 93 million miles across the void of space to warm up our entire planet. That is all thanks to radiation. And bringing it back to our campfire, that cozy warmth on your face, that's infrared radiation, traveling in waves straight from the fire to you.
Okay, here's a wild fact for you. You, yes you, are radiating heat right now. Anything and everything with a temperature above absolute zero is constantly sending out thermal radiation. We can't see it, but if you looked through a thermal camera, you would literally be glowing.
All right, final pop quiz. Can radiation travel through a vacuum where there's no matter at all?
The answer is yes, absolutely. You could even say that's its superpower. It's the only one of the three that can pull that off.
So, we've broken down each pillar one by one. But the thing is, out in the real world, they rarely work alone. They're almost always a team. So let's put it all together now and see how they combine in a super common, everyday example. Okay, just a super quick recap. Conduction, heat by touch; convection, heat by flow; and radiation, heat by waves. Got it? They're three different things, but they love to work together.
And boiling water is just a perfect example of this teamwork. Check it out. First, the stove burner radiates heat to the bottom of the pot. Then that heat conducts through the solid metal of the pot itself and into the water. And finally, once the water is hot, convection current starts swirling around, spreading that heat through all the liquid. See, all three pillars working together just to make you a cup of tea.
So you see, this isn't just some abstract science concept. Conduction, convection, and radiation, these are the invisible forces that are literally shaping our world. They cook our food, they heat our homes, they drive our planet's climate. They're what makes life here possible. They are always at work all around us.
And there you have it, the three pillars of heat transfer. So next time you feel the sun on your face, or you're holding a warm mug of coffee, or you just see soup simmering on the stove, you'll know exactly what's going on underneath. So my final question to you is, now that you know what to look for, where are you going to spot them next?